Welcome to Solutions Studio. This is a free series on C programming language. If you like these videos, please subscribe to follow along with this series. Also, please like and leave a comment and share the video to help spread this series. Hello and welcome to this episode, and in this episode we want to have a look at some more examples that can be solved using recursive functions. One of those examples is the Fibonacci series. The Fibonacci series begins with 0 and 1, and it has the property that each subsequent Fibonacci number is the sum of the previous two Fibonacci numbers. So for example, we start from 0 and 1, and the subsequent number is the sum of these two numbers. So 0 plus 1 is 1. 1 plus 1 is equal to 2. 1 plus 2 is equal to 3. 2 plus 3 is equal to 5. And this is how the series goes on. The interesting thing about this series is that this series occurs also in nature, and in particular, it describes a form of spiral. And the other interesting thing about the Fibonacci series is that the ratio of successive Fibonacci numbers converge to a constant value of 1.618. So this number divided by this, or this number divided by this, and going on like that, they are all going to converge to a constant value of 1.618. This constant value is also interesting for the fact that it occurs in nature, and it has been called the golden ratio. And humans tend to find the golden ratio artistically pleasing. Finally, we can come to the conclusion that Fibonacci series can be solved using recursion, and its final recursion equation can be defined as such. These two statements could be the base case for Fibonacci series. Stay tuned as we are going to solve the Fibonacci series in C programming language in the coming episodes. Hello and welcome to this episode, and this episode let's go and create the Fibonacci series using a recursive function here in C programming language. So stay tuned. Now our program is completed. Let's go and run this program. As you can see, we have calculated the Fibonacci of 0 until 10, and then 20, 30, and 40. Stay tuned as we go into more explanation of this program in the coming episodes. Hello and welcome to this episode, and in the program that we wrote for creating the Fibonacci series, you can see that the Fibonacci function, which is called from main, is not recursive, but all of the subsequent calls to Fibonacci, they are all recursive. Each time that Fibonacci function is invoked, it immediately tests for the base case, if n is equal to 0 or 1. If this is true, n is returned. And if n is greater than 1, the recursion step generates two recursive calls, each a slightly simple problem than the original call to Fibonacci. And that's how finally the series of Fibonacci is created from 0 to 40. Hello and welcome to this episode, and in this episode we will be discussing about order of evaluation of operands in the recursive functions. As you might know that we wrote this program to generate the Fibonacci series. Here in the Fibonacci function we have two recursions happening. Now you might ask which recursion is going to happen first. Is this recursion is going to happen first, or is this call to Fibonacci execution is going to execute it first? And you might have assumed that this statement in the left is going to be executed first, and then this statement on the right, this invocation on the right. But for optimization reasons, C programming language does not specify the order in which the operands of most operators, including addition, are going to be evaluated. Therefore, you cannot make an assumption that this recursive function happened first or this recursion happened second. In most of the programs, whether this function is going to be evaluated first or this function is going to be evaluated first, it does not make difference for the result of the program. However, in some other programs, in specific programs, the evaluation of an operand may have a side effect that could affect the final result of this expression. So in conclusion, we can say that you can never make an assumption for the order of evaluation of operands in C programming language for optimization reasons. Hello and welcome to this episode. In this episode we discuss the operators for which operand evaluation order is specified. So in C programming language there are 4 operators that the order for their operand evaluation is specified. Those 4 operators are the AND operator, OR operator, the comma operator, and this conditional operator, the tertiary conditional operator. So as you can see in here, I have an example for you for AND operator. If A is equal to B and C is equal to D, this is a statement and it always evaluates from left to right. Similarly, we have an OR operator and this also evaluates from left to right. We also have the comma operator. For example, during initialization or declaration of variables, we use the comma operator and this also evaluates from left to right. This tertiary conditional operator, which is the only tertiary operator in C programming language. Tertiary means that it takes 3 operands, and this operator is a little bit different. The way it's different is that if this condition becomes true, this expression 2 is going to be evaluated and expression 3 is going to be ignored. And if this condition is evaluated false, then this expression 2 is going to be ignored and expression 3 is going to be evaluated. And that's how the evaluation order is for this tertiary operator. Stay tuned for more interesting C programming language discussions in the coming episodes. Hello and welcome to this episode. In this episode we discuss about the exponential complexity of a program. So I would like you to be cautious when using recursive programs like the one that we used to generate the Fibonacci series. On each level of recursion in the Fibonacci function, it has a doubling effect. because it creates two other recursive functions. The number of recursive functions that is needed to execute to calculate the end number of Fibonacci number is on the order of 2. That means that this number is going to get out of hand very quickly. And calculating only the 20th Fibonacci number would require on the order of 2 to the power of 20, and that is about 1,000,000 calls. And if we want to calculate the 30th Fibonacci number, that would require even almost 1,000,000,000 calls. So that's why the computer scientists, they have defined this as exponential complexity. Problems of this type of nature, they can humble even the world's most powerful computers. The example we have used in this program to solve and create the Fibonacci series may look appealing, but there are actually better approaches to take and generate the Fibonacci series. Just to see how things can get complex so quickly, let's go and evaluate the Fibonacci number of 50 and see how long it will take for the computer to generate that number. Well, you can see that it's way too hard for the computer to generate, so maybe we can bring it a little bit lower. Maybe let's go until 45. Now you saw that it took about 7 seconds to generate all of these numbers. Now let's try and go until 46 and see the difference. Now you saw that for 46 it took 11 seconds. And I hope that you saw the effect of exponential complexity in this example and in this episode. Stay tuned for more episodes.